Hey everyone, raise your hands if you're listening. All right, we have everybody listening. Now raise your hands if you can see the code. Nobody. All right. So here's what we're gonna do. This is me giving a technical demo, right? A technical workshop. You're gonna learn, or you might even ship your first contract. For that, I'm gonna ask you to move as close as you can physically. Move your feet, move your butts. Come on, everybody. Let's get close to the monitor. And you'll be able to see some contract code. Come on, be brave, everybody. You came to Denver to do this, all right? Let's move on close, move those chairs. Come on. I don't see enough movement here. Come on, everybody. 1, 2, 1, 2. Let's go. This is crypto, right? Everybody's got enthusiasm for this, right? Let's go. I got time for this. We can wait. I need everybody here. Come on, don't be shy. All right, now, there's some seats over at the front. Hey there. You need to, oh, the plug, okay. Battery's dying. All right, appreciate everybody moving up. Now, let's raise your hands who can see what's on the screen, who can see the text. We got an improvement.
Can we make it larger, Morgan?
That's not the point. The point is those people that are up front are going to make it. Okay, so that's how we're doing this. Right, now that I've got your attention, my name is Morgan. Like Julian, I'm a common man, and we're building a platform to onboard common people onto the blockchain to become smart contract developers. So what do we see here? What's on the screen? Can you all read?
Morgan, I'm like right here. I can barely read it. There we go.
Yeah, I don't know. You got to move in closer.
That works. Make it bigger. Like
No, move in closer.
Sir.
Ma'am, please move up closer. So what do we have here? We have a little boilerplate, but first of all, the environment, right? What is this? What are you looking at? Well, top left corner, for me at least, it will be top right for you. It says Okashi. So Okashi is the smart contract playground for Soroban. What does that mean? Well, a playground is a fun thing, right? We go out to a playground, we play with our friends, we build some sand castles, we have no intention or fear of doing stuff there. So this is the concept behind Okashi and it being on Soroban. So there's a few lines on the screen, right? We start off with some boilerplate Rust. This is Rust, by the way. If you're scared of Rust, raise your hands if you're scared of the Rust programming language. Everybody's good with Rust? Okay. I'm scared of Rust, personally. But anyhow, you just import a few handy things from the Soroban SDK, and then you declare a contract struct. So a struct, think about it as like the skeleton where you're gonna put your meat onto. Let's call this token, right? Everybody's into tokens in blockchain. So we're gonna create a token contract. Julian gave a beautiful demo or a slide deck of DeFi, right? But to understand all those, yep. Yeah, please do. If you follow along, you're double gonna make it. This is Okashi.dev. Yeah, sorry, Okashi.dev, everybody. So yeah, the slides were amazing, but if you're like not a super technical person, not a financial person, then that, pretty much above the line, very acidic, very sort of, out there. What does it all mean? Transfer this, that, and the other. Well, we're gonna discover some of the things that means. So to create a token contract, in programming terms, we need to store a number associated with an account, okay? We're just storing a balance. So how do we get started, right? So a lot of these things get started with a mint, right? Somebody mints some tokens. So let's go ahead and create a function to mint some tokens. And we're gonna mint those tokens for a specific address, okay? Now what did we just write? I'm just gonna test whether you guys can see. What did I just write? pub fn, right? Pub fn mint, and two arguments to that function. So this is a public function in our contract, and that function is going to be exposed, just like literally a thing that you can do with the contract. So it's going to be exposed. All right. So this is a point where, and my suggestion with the playground is just run it. Don't wait to complete the tutorial. Don't wait until there's like a checkpoint or whatever. Click compile. And in Okashi, you get a contract in that sort of middle bar there under contract, right? And every public function, which means everything that people can interact with, is going to become a button, right? How many of you like buttons? I click them every day. All right, so we have a button there. This is how you interact with a function. You don't call a CLI, whatever that means. You don't call an RPC. You just click a button. All right, so that's a function. You click a button, and it takes one argument. Now, in the world of blockchain, an address or an account is like a ginormous string with random letters and numbers, right? On Okashi, because this is a platform for the common man, we use names, right? When you want to initiate a call with an account, well, hey, I want to call this function for Alex. All right? Boom. We call this for Alex. Now, we don't know exactly whether this worked or not, so raise your hands, by the way. How many of you are web devs, like, or ever touched a web platform? Everybody, beautiful. So you're familiar with console log, right? Console log is a thing. I'm a huge fan. Like console log is my bread and butter. So can we do this? Let's try it. Let's compile this thing. Why did I do that? This is Rust. This is not the web browser. This is not supposed to work. Well, I did this for two things. One is never be afraid to compile something that looks stupid, okay? The compiler is going to come back to you and he's going to, Rust has amazing messages from the compiler. So it says, cannot find console in this scope. A bummer, right? Console is not available. But what do we have? In the Soroban SDK, we have log, okay? So let's just call log. And, I don't know, let's say hi in the log to recompile this. Oh, we got, another problem. So that's a macro. So a Rust macro, you got to call with a bang after the name, okay? This is how we learn. This is like you're developing an intuition every time you mess up. I mess up like most of the time during my day. Like the end of the day, I might still be messing up. All right, so it's missing tokens and macro arguments. Soroban uses a thing called the environment very heavily, and that goes into many of the function's first arguments. The environment is literally Soroban. The thing your app, your contract is going to run in. Your app is a program, right? When you run your JavaScript in the browser, think of it as a contract running in the browser being your environment. Okay? So we're going to run this in, recompile this. No more errors, by the way. That should feel relaxing. We're going to call this with Alex, and it says hi. All right, so we got some debugging information in there. Let's use this. So like, how many of you would love to see what your function was called? What kind of arguments was it called with? Well, with Soroban, we could just call log, and let's call it with Alex. Account Alex. Can you all see that? Down at the bottom? So you can experiment with your function calls, experiment with your logic, and log it into the console, right, in the browser. Like, what values am I getting? What's changing? What's not changing? Do this as often as you like. I could do this. Don't be afraid. Like, this is good. Logging as much as you can is a good thing. You should learn how to do that. All right. So we just log it. It's free. This is not on the blockchain. This is executing in your browser. Okay. This is super fast. You can, once you compile the contract, you can do this without an internet connection, actually. All right, so we called mint with an account. We know that, let's call it, with Alex, let's call it with Bart. So we can see that changes, all right. So how do we assign a balance to this account here? Mint for whatever. We need to allocate something into storage. So we have our environment from the mint function. That's the first argument, everyone. And there's a storage function inside of there. And let's do persistent storage. There's Soroban special. There's state expiry. Y'all gonna learn about that eventually, and it's gonna be big. But for now, let's just think of this as your contract storage. Okay? So what we're gonna do? We're gonna do this. We're gonna set the balance. Okay? So how do we? So this takes a key and a value. Key and a value, right? A map. We're gonna assign something to something. Let's make sure that there's some a little bit of a nice dressing over an address. So we're going to create an enum for keys. Right? We need a key to store our balance. We're going to create an enum for keys, and the key is going to be balance. All right, and it's going to hold an address. Simple enough, right? Let's import contract type. We're just going to decorate this as a contract type so Soroban knows what's up. And all right, so we're going to set the balance for this account to how much we're going to mint. Let's talk numbers. What's the initial mint going to be like? Throw me some numbers. 10. We got 10. We got 1 billion. Any other suggestions? Be brave, come on. 1 trillion, all right.
How many zeros are in a trillion?
I don't even know. I've never seen a number this big. Let's pick something in between. Let's pick 1 million. Let's pick 1 million, all right? So we're gonna store that in our storage. Let's recompile this. Do this often. Write a line, compile this thing. Oh boy, this didn't work. What happened? Arguments to this method are incorrect, okay? That's sad. All right, let's make sure they're correct. Okay, let's call mint. It's minted for Bart. Mint for Bart, nothing happened. Or at least we don't see something happening. How can we see something happen if we don't log it, right? Let's go to our trusty storage widget, okay? So Okashi has these things called widgets in the left-hand side, and they allow you to observe various things about your contract. So even if we didn't have our trusty log function, and we don't know if something happened, if we put something in storage, well, we open up the storage widget, and here we go. We got a little box there. There says balance, Bart, and 1 million. Now, how about that? Inspecting what you did with storage in a visual way without having to query anything, it's just there, okay? So we got a minting function. And by the way, this is a total YOLO contract. There's no security here. This is just proof of concept, okay? We're not gonna ship this to mainnet. We could, we're not gonna do that. All right, so we got minting going on. Let's mint it for somebody else. Let's mint this for Alex. We got balance for Alex. We got a balance for Bart. Sweet. Now, since we have these millions, right? We got millions of tokens here. How do we use them? Anybody got ideas? Oh, shoot. I have already a suggestion on them. We transfer them, okay? We transfer these tokens because sharing is caring and the community grows when we start sharing. So what's a transfer function gonna need as arguments? And I'm gonna need your help here, I don't know. All right, so we need an amount, okay. What was that, receiver's address? Receiver is gonna be an address. What was that, the token that we're using? Well, this is the token contract, so, yeah. So, all right, we got 2 arguments. Is that, are we good? First one to answer is gonna get a cupcake. What was that?
I was saying you need a sender as well, but I'm assuming you can read that from the transaction.
We need a sender. You are absolutely right. We need a sender. Anybody who's managing the cupcakes, please give that man a cupcake. All right, recipient address. All right, so we got some arguments in there. What do? We compile this thing. because that's what we do. Every time we do it, we compile it. All right, so it compiled, no errors, no bugs. Now let's execute the logic of taking the sender's receiver and recipient. I'm gonna rename this to sender. All right, so we're gonna take some money from the sender and we're gonna put it into the recipient account, okay? How do we do that? Well, we did store something in the storage previously, right? And under this key balance thing right here, okay? So we're just gonna sort of try and reference that. So we're gonna check the sender balance. I'm typing this out live. This is happening. If you blink, you might miss it. All right, so we're gonna do environment.storage. That's how we access storage. Then we're gonna do persistent, okay? And what do you think the name of the method to get an entry for under a key is? What could be the name?
Get storage at.
What was that?
Get storage at.
Yeah, it's get. So pretty nice naming scheme there. Nothing too confusing. I think I'm gonna hide the console so you can see better. All right, so sender balance, we're gonna get from the storage. Now we're gonna get with this key here. And now what we're gonna do now, I need to look, what's gonna happen? I wrote a line of code. What should you do as a developer? This is getting started. If y'all were listening, compile it, yes, because who knows if this compiles? Why are we even moving forward if it doesn't compile? Are we silly? No, we're not. We are very, very smart. So let's log it, by the way. After compiling, if it compiles, we might as well start logging this thing. So let's look at the sender balance, okay? Sender balance, and we can interpolate our strings with this sort of curly bracket, curly brace. I don't know, depends on what you prefer. And we can just send the sender balance. If I could type. Okay, let's recompile this. We added a second line, might as well. Oh no, we got an error. So that's account. We need sender in there instead of account. And that's the way to do it. Mismatching types. Expected U64 found option. All right, so we learned some things from the compiler. We learned things that, hey, we're doing this sender balance thing by just getting a value. But what could be the case if, say, for example, I have never minted that token in my life? That entry might not be there, okay? That's why this thing returns an option. So it's an option. And this is a U64, so we need a number. We can sort of cheat a little bit, and if that doesn't exist, let's call it a 0, okay? Recompile this. We're good. Let's hide the compiler. Let's call transfer. Let's do 10 sender Alex, recipient Bart call. Sender balance 0. Okay, so we got a number that's expected. What if we mint for Alex? Okay, and then we transfer from Alex to Bart. By the way, Okashi remembers your last arguments. So if you want to call this thing quickly, your arguments are going to be there. So we click call, and we got a panic. Okay. What's this panic about? I don't know. Send a memo from Alex to Bart. So that number should be good. Let's do some live debugging. If anyone catches the bug, you get a second cupcake.
I think you minted it for Bart, not for Alex, so I don't think there's any balance for that.
All right, so let's check the storage widget. Alex has a balance. I call transfer 1 from Alex to Bart. We get a panic. If I call transfer from Bart to Alex, we don't get a panic. So that means when this unwraps, then what if this is U64? Let's mint Alex. Let's transfer Alex to Bart. All right, so what happened there? What do you think? Why was I crashing and so horribly embarrassed by that bug? Data that we put on the ledger, that we put in storage, gets serialized, and it gets serialized as a specific type, so that the contract and everybody else knows what those bits are to later deserialize them. And when I stored this, it sort of, I don't know what this is. This is an I-64 maybe, whatever it is. And then I was unwrapping that as a U-64, and then the system's like, nope, not gonna allow it. Okay, so we got center balance. We can do this nifty trick that every developer is familiar with called copy and paste. It's very famous, very popular. So we do recipient balance over here, and we do recipient address over here. Let's look at the balances. Oops, why did I do that? Let's do recipient balance now. Let's mint Alex. Let's transfer 1 from Alex to Bart. Looking good? Is this correct? Everyone, raise your hands if you think this is correct so far. This is free auditing. I'm just, piggybacking off of this audience. Is this good?
How do you verify the color you send it?
How do I verify who's the sender? That's a good question. Let's do require auth to make sure that the sender is actually the sender. That's a good point. What else is kind of a thing?
Don't you have to add the amount?
Duh. That's it. Yeah, exactly. We have to change the balance. Because what's the point of a transfer if we just look up the balances? That's a silly function. We should not have any silly functions in our contracts unless we're doing some circus clown stuff. So what do? We recipient balance, we add the amount, right? We add the amount. Is that right, sir? Okay. Okay, let's compile. We added a line of code. We must compile this thing. Let's mint some stuff for Alex. Let's transfer from Alex to Bart. All right, and probably let's do a console log to make sure, let's do AF or, 2.0, whatever. Be creative with your naming and your logs.
You also subtract them.
There we go. You are a great developer, sir. I was about to go on this elaborate journey of discovering this bug, but you solved it. Thank you. All right, so center balance, we got to subtract that. All right, so we're subtracting it from the center balance. This looks good. This looks promising, right? Let's compile it. We added another line of code. We need to compile it. Mint transfer. All right, so these logs are looking good. Sender balance was 1 million. Center balance became 999,999. But thanks for the suggestion with the big numbers. Easy to say that. And then the recipient balance is 1. Let's do another transfer. 1. Let's send. Let's be generous here. We got 1 million. Let's send 1,000. What happened? Is it good? Woo! Man, we got really good developers out here. So, the numbers didn't change from the previous one. Seemingly it should have been different. All right, so this is where logs come in and play a big part. How long would this have taken you to discover? If you're like a newbie, you're just discovering smart contracts. How long would this take with RPCs and CLIs and whatever else? Pretty long time, right? We're just we're hashing this out. We're jamming, we're jazzing. We're doing this live. All right, so what we're gonna do. We have this persistent set thing. We're gonna copy that. It's not beneath us to copy and paste. So we're gonna take the sender balance and put that here. We're gonna take this, copy paste it again for the recipient, booyah, and the recipient balance. We added a couple lines, let's recompile. Ooh, what's that? If you're familiar with Rust, this is a thing that might sort of start irritating you at some point. Rust has no garbage collection, but it has memory management. Yeah, you got to be careful. So whenever you move things, you lose the ownership of them, you gotta fix that. So we have a bunch of issues here. So sender and recipient, those are complex data types. They're moved. So we're gonna clone these so that we still have a sender and a recipient available to us. That compiled, okay. So let's look at our storage. And in fact, I'm gonna hide the contract. Hey, this view we didn't have before, but now we have it, right? So let's mint something for Alex. Now, so we're looking at the storage and the console. Let's do a transfer. How many tokens do we send to Bart? I'm taking requests. How much? 500. 500 going once, twice? Okay. We're sending to Alex, from Alex to Bart. Booyah, all right? So we look at our storage widget here. We went from 1 million to 999,500, and Bart is at 500. What we can do now is send from Bart to Alex, I don't know, 50. And we can, here's a fun fact. Okashi, if you have stored and cached arguments, like in this case with the transfer function, you can hold down Shift and just sort of click, 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 spend your money. All right? This is a fast way to test your contract without having to do like anything, really, just click. Now what happens is if I click transfer again? Let's look at the arguments. 50 going from Bart to Alex. What do you think? I don't know, I've never ran this before, so I'm interested myself. What was that?
Get reverted.
A little louder, please.
Get reverted.
So,
I can't remember.
well, let's look at the contract. So in the transfer function right here, we're getting some balances. We're updating those values. We're putting those balances in storage. And so at this point we have, that reset. Every time you sort of compile this, it resets the storage. But it remembers the arguments, right? No, it doesn't. Let's mint Alex. Let's transfer 500 from Alex to Bart. And let's do 100 from Bart to Alex. And let's do it a couple times. 1, 2, 3, 4, 5. We get a panic because we're storing our balance as a U64. You cannot go in the negative. So that's kind of like an implicit safety feature. If you don't want to, if you want to YOLO, but you got still some wits about you. It's not past 12 or whatever.
Interface has signed values.
Transfer has signed values?
Because someone might use negative balance for some reason.
Well, the argument, by the way, if you open up the thing here, it says what kind of number it accepts, and it accepts a U64. So if we want to type a negative number, right? Let's do 100. The UI here tells us that the number needs to be greater than 0 if you want to submit this. So the interface is sort of very deeply connected with the underlying type system to guide the users that are interacting with your contract. And if, for example, I had some friends and I wanted to share this contract. What do you think this is? Anyone wants to pull up their phones real quick? This is just filler for my time slot. I'm trying to. All right, we got some phones out. You guys are gonna make it. Those with the phones, you guys are gonna make it. Can you tell me what's going on the phone? The workspace. By the way, we don't have a mobile friendly thing. It's it might not even work. Probably won't work. But the goal is to make it work on mobile so you can share. But you can share this workspace with people that are not technical and be like, hey, my contract is these buttons. What do you think? You know, and they can interact with it and see the results. And if they like your contract here, they might YOLO into your mainnet contract, or I don't know, could be an early marketing gimmick. So yeah, anyone that's followed this thing is going to make it, and you're a contract developer officially at this point. So you're a builder. Go to the main stage, ETHDenver, and start building. This has been me, Morgan, a common man, just developing contracts. Thank you so much for the attention.
Can I just say one few words right here? We were actually not kidding about the cupcakes, so we also have some cupcakes for you. I know there were free cupcakes earlier, so feel free to get them. They're right over there. Lena is pointing to them. Do you guys want to say a few words? Phoenix? Yeah, just like a quick 5 seconds here about what is Phoenix and what are you guys building?
Yeah, sure. All right, so who's ready to get souped up with Phoenix? Anyone who may know us or not already? So we thank you very much for the invite that we got maybe about 20 minutes ago.
Yes.
We just got here yesterday and we're unsure that this event was happening, so we don't have a computer.
Okay.
But anyone who kind of wants to see what the app looks like currently can head on over to phoenix-hub.io. But for those that don't know us, what we're really doing is harnessing the power of Soroban, which is changing the landscape in Stellar to allow for a DeFi hub. That is really our goal. And we're going to be starting that by launching a decentralized exchange, which has been live on testnet for a while now, and we're ready to deploy when Soroban is ready. So
Which it is right now. It's live on mainnet.
Yeah,
Today.
exactly. So when you first get into the page, you'll see a new user guide. So with that, you'll be able to, with DeFi being new to Stellar, it's going to be good to have new users have a nice tutorial, go all the way through, see how to connect your wallet, how to deposit assets, everything like that. So it's going to be really helpful there. It's going to have all the basic things that a DEX has, like trading, swapping assets, LPing, and then we're adding something additional. At the very bottom, you'll see a trade history. So you'll have a detailed trade history of everything you've had and then all the trades that have been done on the exchange. So it's a really detailed and well done DEX. But then you may ask, so how is that a DeFi hub if you're just launching a decentralized exchange? Well, for those of you in the know that last week we just submitted another SCF 24 grant proposal to create an NFT marketplace on Soroban. So this will be built on top of our decentralized exchange, and there will be 3 main things that come with this. It's going to be creating a Soroban NFT standard. And the essential piece with this is that when other people are using this, if other people implement NFTs, if they're not all using the same NFT standard, they're not going to be compatible with each other. So you don't want a bunch of different protocols with a bunch of NFTs all stuck on that one protocol. So with this, it's going to be a public good that anyone developing on Stellar can use and integrate to create their own platform and NFTs. Additionally, with that, we're going to be incorporating all NFTs onto our detailed dashboard that is already going to be on the deck. So any NFT that you have on Stellar, you will be able to see on the dashboard. And finally, we're going to have the auction house where you can buy and sell all your assets. So that's just a little quick thing on Phoenix, guys. I'm really excited to be here, and thanks for listening.
Phoenix.
For Phoenix, exactly. And we have a little bit of a couple gifts here. It's actually quite practical because we are giving a little cool beanies.
Whoa.
Right for windy
Let's
weather
go.
in Denver. So feel free.
I thought it was actual pho. Like I really thought it was pho boxes.
I had some food safety issues.
I really did. I was like, oh, are we carrying pho around?
Yeah,
But
so,
yes.
so feel free, whoever wants to, treat yourself, please. There are also some cards. If you didn't get the address, there's a QR code behind you can use. So,
Yeah.
We got a few more over there.
exactly. So, yeah, thank you for warm welcome.
Of course. Thank you guys. All right, thank you all so much. That's it from Stellar and Soroban. If you have any questions, come talk to me. Happy to answer anything.
Well,
I was really
thanks
fooled by the
again.
food for-
Amazing workshop, definitely. We were totally mind blown by the online IDE. Compared to my experience with Remix, it's definitely one of its kind. So